Hi, thank you for watching this video. My name is Miao Jiang. I work on the Azure API Management team. In this video today, I'm going to talk about how to build a CI/CD pipeline for Azure API Management. When we go talk to our customers today, one of the most common questions they ask is, how do I build a CI/CD pipeline to automate the deployment of my APIs into API Management? Essentially, an effective CI/CD pipeline can ensure the agility of publishing your APIs without jeopardizing the stability of running them. However, as soon as you start thinking about building a CI/CD pipeline to automate the deployment of your APIs, you will quickly run into a few challenges. We know that organizations today use multiple deployment environments, such as production and development. If I'm an API developer, once I have finished developing and deploying the backend service of my API, how do I automate the deployment of my APIs into API management? That's the first challenge. And second, once I have tested my API in the dev environment, how do I migrate all the configurations of this API from one environment to another? That's the second challenge. Some of these configurations include API definitions, policies, named values, diagnostic settings, and so forth. And finally, we know that API management is often a shared asset between multiple API teams. So if multiple teams are making changes to a shared API management instance, how can we make sure that they do not step on each other? That's the third challenge. And unfortunately, there's no one-size-fits-all solution here because there are multiple factors you need to consider. For example, what is your team structure? Do you have a single API team or do you have multiple API teams? And also, what's your engineering culture? Is it a low-trust culture where you have a central team who's responsible for everything? Or is it a high-trust culture where each API team is responsible for deploying their APIs directly? And second, you need to think about how to implement your CI/CD pipeline using your existing tools. And finally, as an Azure service, API management obviously supports a variety of deployment options. For example, there's the Azure portal, which works for some customers who have few APIs and who do not need to update their APIs very often. But using the portal is certainly not an automated approach. You can use the management API or PowerShell to automate the deployment of APIs. However, to some customers, it feels a little bit imperative. We also have the classic Git deployment feature, which we shipped about 4 years ago. It works for some customers, but it also has its limitations. For example, it does not support RBAC, and it does not support partial deployment, which means that if I just need to deploy a single API, I still need to deploy everything, all the files from this repository. And also the files in this repository uses our custom JSON format, which is not consistent with the rest of Azure. And finally, there is the Resource Manager templates, aka ARM templates. So if you are starting from scratch today, this is our recommended deployment option for a few reasons. First of all, it is very easy to automate the deployment of your ARM templates, and it's also consistent with the rest of Azure. And ARM templates, they are also declarative and idempotent. If you modularize your templates properly, you can also do partial deployment. It gives you a lot of flexibility. And finally, ARM naturally supports RBAC. So with that being said, let's take a look at a suggested approach of implementing your CI/CD pipeline by using ARM templates. Okay, so in this example, let's say my organization has two deployment environments, production and development, and each of these environments has its own API management instance. The production API management instance is managed by a central team called the API publishers, and API developers who work on APIs only have access to the development instance for testing their APIs. The key in this approach is to keep your API management configurations in ARM templates, and you need to keep those templates in a source control system. In this video, I'm going to use Git as an example, but you can use any source control system that you prefer. So as you can see, for my production API management instance, I have a Git repository called the publisher repository, which contains the configurations of this instance in ARM templates. And in this repository, there are different types of templates. First of all, I have a service template, which contains all the service level configurations of this API management instance, such as custom domain names, number of scaling units, pricing tier, managed identity, and so forth. And then I have a bunch of shared templates for shared resources in this API management instance, such as products, groups, loggers, and so forth. And finally, for each API, I will have one or more API templates for the configurations of this API. such as API definition, policies, named values, diagnostic settings, and so forth. And each of these templates can be deployed individually. So if I just need to deploy a single API, I can just deploy the API template for that API. And if I want to deploy everything all together, I can also use a master template, which links to everything. Okay. And then for API developers who work on APIs, they will fork and clone this publisher repository into their developer repository. And then they can work on the templates for their APIs and deploy their APIs in the dev instance for testing their APIs, right? However, if we think about this approach, there are two challenges here. The first challenge is that we know that some customers, they still prefer to use the Azure portal to manage and configure their APIs. So once they have finished configuring their APIs, how can we help them to extract their configurations from API management into templates so that they can migrate those configurations from one environment to another? That's the first challenge. So for that challenge, we have created a utility tool called the extractor, which can help customers to extract their existing configurations into templates. And then the second challenge here is that we know that API developers, they often work with open API specification or Swagger file, right? So they may not be necessarily familiar with the resource manager schema. So for those developers, once they have an open API spec created for their API, how can they easily create an template to deploy that open API specification into API management? That's the second challenge. So for that challenge, we have created another tool called the creator, which can help you to create an template that deploys your API definition. Essentially, the tool takes an open API specification file as the input, and optionally, you can also provide the policies you want to apply to this API or its operations in XML format. The tool will take the open API spec as well as the XML file and generate the templates for your API. So with these utility tools, it greatly simplifies the creation of your templates for your APIs. And once the API developers have the templates created for their APIs and have tested their APIs in a dev instance, they can create a pull request back to the publisher repository to merge their changes. And this is when the API publishers can validate those pull requests to make sure that they are safe and compliant. And a lot of these validations can be automated. And after that, the pull request will be merged back to the publisher repository, and the changes can be published to the production instance. So this is the conceptual flow. And if we think about that, there are multiple benefits here. First of all, since everything is in templates, it is very easy to automate your deployment. And second, again, since everything is in templates, it is very easy for you to migrate your configurations from one environment to another. And third, since different API teams will be working on different API templates, different files, right? So it is less likely for them to collide with each other. And finally, this is a very flexible approach. You can easily adjust it to fit your own requirements. For example, instead of having a central API publisher team, you can actually allow each API development team to deploy their APIs into the production instance directly with proper RBAC setup. And second, you can also use different tools to implement this flow. Or instead of using multiple repositories, you can also use a single repository with multiple branches. So this approach gives you a lot of flexibility. So everything I've just talked about, including the guidance as well as the tools, they are published on a GitHub repository. You can find it here at this link, aka.ms/apimdevops. And the tools, they are open sourced, so you can customize and extend them to meet your own requirements. And we also greatly appreciate community contributions into these tools. So with that being said, now let's take a look at a sample CI/CD pipeline that I implemented by following this approach. So let's say I am an API developer, and for my organization, I have just created a new API called Food Truck API. Essentially, it returns a list of food trucks that are available in our office today. And I have deployed the backend service of this API to an app service. So as you can see, this is my app service. And if I click on the browse button here, essentially I have a very simple JavaScript page which calls my API and returns the list of the food trucks. And I have also a Swagger file for this API. Here you can see this is my Swagger file. So at this point, I'm ready to publish this API through my API management instance. However, as an API developer, I am not very familiar with the resource manager schema, so I'm not sure how to create an ARM template to deploy my API by using this open API specification file. So this is our automation tools come into play. So in this first demo, I'm going to show you how to use the creator tool to create an ARM template that deploys my API. So let me switch to my VS Code. So this is my VS Code. In the Explorer here, you can see under the FoodTrucks API folder, there are 3 files. These are the input files for the creator tool. So the first file here is the Swagger for my API, which is very simple. And the second file here is an XML file, which essentially is the policy that I want to apply to this API once it's published through API management. You can see that it's just a rate limit policy for this API. And then finally, there is a YAML file, which essentially is the configuration file for the creator tool. It basically tells the tool how to generate the ARM template. So you can see that this is the name of my Dev API Management instance. And I'm telling the tool that please create a version set for this API. And here are the metadata for the version set. And then for the API itself, this is the name of the API, the version set ID, revision, and so forth. And also, I'm providing the link to the open API specification file as well as the XML file, which contains the policies. And more metadata such as suffix, protocols, products, and so forth. Okay, so now I have all the input files ready for the creator. Let me go to my command line here to run the creator. So let me copy this command. And let me clear this and paste this command. So now it will run the creator. Okay, it has just finished. So now under the templates folder here under FoodTrucks API, you can see that a bunch of files have just been created. So let me walk you through these files. So first of all, you can see that we have a template for deploying the API version set for this API, right? Which you can see it has all the metadata about this version set that I provided through the YAML file. And then there is an initial API template, which essentially creates this API with all the metadata, such as name, path, protocol, and so forth, right? And then there's a subsequent API template, which essentially imports the Swagger file into the API that we created, and then applies the policy using that XML file that we provided. And finally, it's associating this API with a product called starter. This is all according to my YAML specification file, okay? And also it has a master template here for this particular API, which links to all the templates that are generated for this API. So if I want to deploy everything for this API, I can just deploy this master template, okay? So now the next thing I want to do here is that I also have a master template for my API management service, for my API management instance, right? So in this case, I'm going to add an additional step here to deploy this FoodTruck API. So let me click on this file. And I already have the content, the JSON prepared. So as you can see, I'm adding another deployment here to deploy the master template of that API, of the FoodTrucks API, okay, which will deploy all the other templates for me for this API. So let me save that. Okay, so now we have all the files ready. So let me go and check in my changes into my developer repository, which was cloned from the publisher repository. Okay, so let me go here. Let me refresh this. Yes, these are all the files I want to check in. Okay, and let me say, okay, added a new API as the message. And let me push it to my developer repository. Again, that's the developer repository, which was cloned from the publisher repository. Okay, so now I have checked in my change. Let's go to my Azure DevOps and take a look at my build and release pipeline. So as soon as I checked in the changes to my developer repository, it will trigger a build release pipeline to deploy my changes to the development instance. Development API Management instance. So if I go to my pipelines here, if I go to build, okay, so as you can see here, my build pipeline for the dev instance is currently running. So if I show you its definition here, it is very simple. There are 3 steps here. The first step here is essentially using the Azure blob file copy action to copy my templates from my private Git repository into Azure blob storage, because ARM cannot access my files in a private repository, so I need to copy them into a storage account. Okay, So you can see that I'm copying the files from the templates folder into my blob storage, and here are the blob storage name and the container name. Okay, and then in the second step here, I'm using the Azure deployment step to essentially validate the syntax of my templates. So as you can see in the deployment mode here, so I'm actually using the validation only mode. So this will actually validate the syntax of my templates, and it will not actually deploy those templates. Okay, and then finally, once the validation passes, then the build pipeline will publish the build artifacts, which are the templates themselves. And as soon as the build finishes, it will trigger my release pipeline here. So as you can see, my release pipeline is currently running, right? So if I show you its definition, it's very simple. There is only one step here, which essentially uses the Azure deployment step again to deploy my templates. So this time, under deployment mode here, instead of using the validation only mode, I'm actually using the incremental mode, which will actually deploy my templates to my dev instance. And if I scroll up here, you can see this is the resource group of my API management instance, right? This is the location of it, and the templates are available at linked artifacts, and this is the link to my master template and its parameters. And here I'm overriding the template parameter to make sure that it's deploying to my dev instance, right? So I'm overriding the API AM service name here to be the name of my dev API management instance. Okay. So now let's go back to the release status and see if it has finished. Okay, so now my release has completed. Let's go ahead and go to my dev API management instance and take a look here. So if I go to my API list, as you can see, if the food trucks API has just been deployed to my API management instance in the dev environment. So if we go to the test here, and just to make sure that the API is working. Okay, so we just got a response from this API. So now everything looks good, right? So at this point, I'm ready to publish this API through my production API management instance. So as we mentioned before, as an API developer, I do not have access to the production API management instance, right? So in that case, in order to publish my API through the production instance, I will have to submit a pull request to the publisher repository, right? And the pull request will include all my templates here. So let's go ahead and go to my Azure DevOps again. So if I go to repos here, it already knows that I have recently checked in something, so I can just create a pull request from it. And yes, so these are all my files for the food trucks API. And let me just create this pull request. And as soon as pull request is created, it will actually trigger a webhook that my organization implemented to validate that my templates are safe and compliant. And as you can see, we just got a response back from the validation service saying that only HTTPS is allowed in protocols. Apparently, I made a mistake somewhere, right? So let me go back to my VS Code. If I look at my API template, apparently under protocols, I specified HTTP, which my organization does not allow, right? So let me correct it to be HTTPS and checking the change again. And push it to my repository. So the pull request automatically picked up my recent change. So now it will trigger that validation process again, and we should, oh, actually we just heard from it, and it says, okay, now it's approved for merging, right? So at this point, my job as an API developer has finished. So let me switch my hat here. So let's say I'm an API publisher who manages the production API management instance. So as the API publisher, I just saw a new pull request came in. So I come to this page, and I see that the pull request has passed the automated validation, right? And optionally, I can also manually review all the files in this pull request to make sure they look good. And after that, I can complete this pull request and merge the changes to the publisher repository. Okay, so now this pull request has been merged. So as soon as I merge this pull request, it will actually trigger a very similar build and release pipeline to deploy my changes to the production instance. Because they are very similar to the pipelines of the dev environment, so I'm not going to show you here in this video. So at this point, you have just seen the first demo where I used the creator tool to create an ARM template to deploy my API into API management, right? You've also seen the sample CI/CD pipeline that I implemented using Azure DevOps by following the suggested approach, right? So in the next demo, I want to show you how to use the extractor tool to extract your API management configurations into ARM templates so that you can deploy your changes to another environment, okay? So let's go to my API management instance again. So as you can see, in addition to the food track API here, we also have another API called Demo Conference API. Okay, so let's say that I have configured this API using the Azure portal, using the web UI, right? And at this point, this API has been tested and everything looks good. So I am ready to promote this API to my production instance, right? So I'm going to use the extractor tool to extract all the configurations of this demo conference API so that I can migrate its configurations to a different environment. So let me go to my VS Code again, and let me go back to my snippet, and let me copy this command, okay, and I paste here. So essentially what I'm doing here is I'm running the extractor. I'm extracting from this API management instance. I'm extracting this particular API called a demo conf, right? And this is the folder where the files will be placed. Okay, so now you can see the extractor is running. It found the API. It also found all the operations under this API, as well as other entities. Okay, so now the extractor has finished running. So if we go back to the Explorer, if I go to the templates folder, under Conference API here, you can see all the templates created by the extractor tool. So as you can see, this is the template for the API. So if I close this thing here, so this is the API itself, and you can also see that it also extracted its schema, right? As well as all of its operations, right? And if we scroll all the way to the bottom here, it also extracted its policy here, right? And the policy file has been placed here in an XML file. So if we look at this, the folders here, there's a policies folder. Under here, there is your XML file. So this is the policy of the demo conference API, right? So as you can see in the counter key attribute here in the rate limit policy, I used a named value called rate limit key, right? So if we look at the named value template here, you can see that the rate limit key has also been extracted. That's because the extractor is smart enough to know that it needs to extract all the dependent entities of this API. So this is how you can use the extractor to extract your configurations of an API into ARM templates, and now I can deploy this template to a different environment. Okay, thank you for watching this video. I hope it is helpful. If you are looking for more resources around API management, here is a link where you can find everything. Thank you very much. See you next time.